Excuse me, sir. You are muted, I think.
Oof, sorry. Okay, so we have mentioned about fluidized bed reactor in the last
Yes,
class.
sir.
So fluidized, yes.
Yes, sir. Yes.
So in fluidized bed reactor, we always try to maintain higher upflow velocity. It is more than 8 meter per hour, and in fluidized bed reactor, we get some inert material as carrier material, and just outside the inner material will have inert core will have the biofilm. So essentially in this particular configuration you will have a fluffy biofilm at the outer layer, and the inner core you will have the inert support material. That support material could be made of polypropylene, polyethylene, PTFE, or activated charcoal particle, sand particle, or pumice stone. Different kind of material you can use, but you have to make sure that that particular material is not interacting with the biofilm. Now you maintain the upflow velocity in such a way that all granules will be fluidized in the reactor. So you'll get good active transport, and that will also help in achieving conversion at a faster rate because you will get more contact. So it will give you higher conversion. And whenever you have higher conversion, you can reduce the size of the reactor. So only problem is here you need to maintain higher flow rate, upflow velocity. And when you have this fluidized condition in the reactor, the granule, because biofilm is not very robust in structure. So whenever you have higher abrasion, like when you have movement of this granule inside the reactor, they will try to come in contact with other granules, and due to abrasion, some biofilm will actually uh, come off from this particular inner system, and then the biofilm will go away from the system along with the outflow. And smaller granules will also have the tendency to go out of the reactor. So you will have entrainment loss when we use this fluidized reactor system. Now, hybrid anaerobic reactor system, we use concept of fluidized bed reactor as well as the USB. That's why it is hybrid of fluidized and USB. So here we maintain flow rate less than 8 meter per hour. So fluidization is done at a lower velocity, and also instead of using any granule having inert support material, we just have biogranule where core is also formed once of bacteria. So they are more densely packed, and also their weight is a little bit less compared to the other granule where you have inert core. So if you try to measure the weight of same volume of granule, then self-immobilized granule will be little bit lighter than the immobilized granule on an inert surface. So in this reactor system, again, we'll get almost all characteristics of fluidized bed reactor. Only difference is upflow velocity is less, so the energy cost will be less, and you can get good performance comparable with your fluidized bed reactor system. And another advantage is as this inert material is replaced by some group of bacteria, essentially in the same volume, you are getting more biomass. So essentially, you can get little bit higher conversion compared to the standard fluidized bed reactor system. So these are the characteristics of this hybrid anaerobic reactor. And this is a picture of the hybrid anaerobic reactor in slab scale we developed in the lab. And when you take photograph, like the way we have seen earlier, if you take the surface photograph, then you can see this kind of surface morphology. Like different kind of bacteria, they will just make a mat or a film on the surface. And at different level, based on the substrate availability, you can see abundance of different kind of bacteria. So in the earlier part, it's showing the upper port of HAR. Upper port means the upper section of fluidized bed reactor, hybrid anaerobic reactor. You get different kind of biofilm compared to lower port because substrate concentration may vary at different level. So this is a example of the pilot scale system we have installed in Delhi mill scheme, and these are the characteristics of effluent and also treatment hour. The remarkable thing is the treatment time is only 2 hours, and inlet COD is quite good, above 1000, and outlet COD is 100. So that means you can say we are getting more than 90% removal efficiency. And along with that also it can produce substantial amount of biogas. And the reactor volume is not very big. It is only 800 liter. So 10,000 liters is getting treated in 2 hours HIT. So 800 liter reactor volume is sufficient enough to treat 10,000 liter of effluent per day. So that means the overall treatment capacity of this reactor is 10 KLD, 10,000 liter per day. So this is a picture of that reactor. And
Sir, where it is situated? You said that?
A Delhi mill scheme. Because although if you visit that place now, you'll not be able to see it because they didn't keep that reactor there. Because whenever you have lower concentration of substrate, we have mentioned here inlet COD is 1200. But if you get lower COD, suppose say 500 or 600 COD, then granule will not stable there because most of the granule will get disintegrated because of low availability of the substrate. So whenever in industry, if they have any fluctuation in the effluent quality, then obviously the granule will not sustain. And exactly that happens. So whenever you will have failure of the reactor system, they will not show any interest. But we have seen if you have substantial amount of biomass, substantial amount of carbon present in the wastewater, then you can easily use this kind of reactor to get good amount of biogas. See, 10,000 liter it is treating, and it is producing 800 liter per day, where methane content is around 65%. So we have seen that lab scale as well as pilot scale, this reactor can work. I mean, in larger scale also it can work. Only thing you have to ensure this substrate concentration or wastewater strength. Similar kind of treatment systems can be developed. It is actually example of trickling filter. Trickling filter type of reactor can be used for treatment of different industrial wastewater. And typically in industry, you get lot of combination of different kind of reactor system and controller to have control environment in the reactor system. So here is actually showing a typical anaerobic reactor. So this is your main reactor, but to manage the reactor, you will have multiple other accessories to make sure that the reactor is unaffected even if you have little bit variation in the input parameter or environmental conditions. We have already mentioned about this particular scheme that you have a centrifugal relation between different kind of bacteria, and based on their centrifugal relation you get the overall performance of the anaerobic digester. Okay, so now anybody has any question on this wastewater treatment system? So essentially in wastewater treatment system, we have discussed about activated sludge process, we have discussed about anaerobic reactor. These are the two prominent reactor used for treating sewage, and our ultimate objective is to get more biomass, so we can actually get better treatment at a smaller time, means in a reasonable amount of time. So that will also help us to reduce the that will also help us to reduce the reactor size. And we have also shown that when you try to compare with aerobic and anaerobic treatment system, inherently the reaction rates are much faster in aerobic system. That's why you need lower volume. whereas in anaerobic reactor system, the volume requirement is little larger because the slow growing anaerobes. And aerobic reactor would require a lot of aeration. That is one of the major expensive part involved in the treatment process. And anaerobic reactor doesn't require any external aeration, but the system is more sensitive, and also you need larger volume. And advantage with anaerobic reactor is you don't use that much energy for operation, and also at the end you get lot of biogas, which can help you, to generate revenue, because if you just convert that energy of biogas to any other thermal energy or electricity, then you can generate revenue from them. And difference between aerobic and anaerobic is also quite prominent when we talk about wastewater characteristics. So if the wastewater contain low amount of carbon, then it is always preferred to use aerobic treatment system, because it is easy to treat and you don't need too much of oxygen for oxidizing the carbon or low amount of carbon. And wherever you have higher amount of carbon present in the wastewater, there you prefer to use anaerobic treatment system, because you will get more methane. And anaerobic treatment system also suitable for treating high strength wastewater, or wherever you have
Sir,
high level of carbon content.
sir, in one slide you shown that like 60 to 70% methane is obtained like in gas. So like
Yeah.
in for a thousand liter reactor system, how much gas is produced like in kg per day, something like that, something I just wanted to know.
So you can convert. So if you know the temperature, so generally for gases, we don't express in kg for that reason. Means if you know the temperature and pressure, then ultimately you have to store the gas in a specific balloon or specific
Yes, sir,
cylinder. So
even
you
the volume.
volume, yes. So there we are talking about 800 liter per day, and 800 liter per day biogas also has 65% methane. So essentially, even if you consider 60% methane, so then you are getting almost 500 liter biogas per day when you treat 1000 liter or 10,000 liter water, where the COD value is 1200 milligram per liter. So if you get little bit higher strength wastewater, suppose COD value is or BOD value is 10,000 or 15,000 or even 50,000, there you can actually get more amount of methane. And obviously we will require more biomass to produce the methane. So those kind of reactors are also available mostly in brewery industry, and that means distillery industry. They use spent wash, or sometimes even the process of they use molasses, which has lot of carbon. So molasses will have COD in the range of say 1,50,000 or 2 lakh ppm, 2 lakh mg per liter. Now, when you use molasses, or when you get spent wash in the wastewater, you prefer to use anaerobic digester, because the methane potential is huge, and essentially you can get lot of carbon converted to methane, and that methane can be used for generation of energy. So it is a common practice in distillery industry to use anaerobic digester to treat the effluent obtained from the industry. And obviously, when you have higher carbon content, you can calculate. You can calculate how much methane you can get from 1 gram of carbon. That you can calculate. If you
Sir,
just
you
convert,
just talked about like molasses. What is molasses?
molasses is again a byproduct from sugarcane industry, and it is you can say sugary substance is present. So in molasses, you get a lot of unconverted sugars, and that sugar can be, but obviously you will not be able to use it directly in any other process unless you use that molasses for growing certain organism. So now we'll start discussing about other organism. there you can see the use of molasses. So it is for one industry, it is waste. For another industry, it is actually not waste, it is actually raw material. So sugarcane industry, for them it isn't waste, because when they manufacture sugar, they get the molasses as their raw material, waste material. Whereas brewer industry and also some other industry where they use molasses as food substrate, their molasses can be used as raw material. So it is essentially a viscous liquid having a lot of residual sugar. So it is a black color liquid. It has a lot of residual sugar, and you use it as substrate in beer industry and also production of different biomasses. Now we'll. Anybody have any question on wastewater treatment system?
So it's clear.
Sir, why exactly more COD is required for well functioning of the plant?
Okay, so for aerobic reactor, just give me a second to share the slide. Just one second. Okay, we have mentioned aerobic process or anaerobic process. Our ultimate objective is to remove carbon to CO2 or carbon to methane. So whenever we use carbon to CO2, we just use oxygen to oxidize it, and in absence of oxygen, it is actually absence of oxygen, or minus O2 you can say. In absence of oxygen, we just convert to methane. Now, in aerobic process, you can see oxidation of carbon is actually happening because of supply of air in aerobic reactor. So this is air, and you have carbon present in this system. Bacteria will use oxygen during their metabolic activity, and then they will convert this carbon to carbon dioxide. A carbon dioxide will come out from the reactor system. Whereas in anaerobic system, we deal with a closed vessel where the granules are present in the reactor to supply effluent from the bottom, and from top you will get methane. So if you have higher carbon, you need to provide more oxygen, because stoichiometrically you need to provide more oxygen to neutralize that carbon. So if you have higher carbon, you need to provide more oxygen. So we know that a aerobic system in operation, so for any treatment plant, you have two types of expenditure. One is the fixed expenditure, means you just, for installation of the system, you need to invest certain amount of money. And in operation and maintenance also, you need to spend certain amount of money. So the recurring expenditure is actually this operation and maintenance, and within that operation and maintenance cost, aeration is having significant share. So if you need to aerate the liquid significantly, then you have to spend a lot of money. So that's why system having low carbon content or wastewater having low carbon content is preferred in aerobic reactor, because aerobic reactor is more stable, it is very easy to build, it is very easy to operate. So a lot of other advantages are there. Only drawback is cost due to aeration. So if you feel that you have very low carbon content and aeration is not that expensive, then you can just choose aerobic reactor system to treat low carbon content wastewater. Whereas anaerobic reactor like USB or hybrid anaerobic reactor, inherently you just you don't provide any oxygen. So operation maintenance cost required for aeration is nil here. It is 0 for anaerobic system. Only cost is the blade fluidization velocity maintained by this particular pump. So that you have to do, and that cost is not very significant or very high. Now, in this particular case, if you have high carbon, then all the granules, because we have mentioned about 4 different reactions: hydrolysis, acidogenesis, and methanogenesis. So all 4 reactions are in series. So they have dependent on the earlier group. So the centrifugal activity of this different bacterial group will actually help you to get carbon to methane. So if you have higher carbon content, then it is more favorable for this kind of reactor. So that's why when you have high concentration of carbon in the wastewater, you prefer to use anaerobic reactor system, although you have to use little bit bigger reactor volume, but still you prefer to use it because the amount of methane you can obtain from the system can give you a lot of revenue, because you can get a lot of energy by burning this methane or converting this methane. Problem with low strength wastewater is you will not get sufficient amount of methane, and also whenever you have low strength wastewater or low carbon wastewater, the granule present in the anaerobic reactor will not be very stable then, because if you have low concentration of carbon in this series of reaction, you will have some sort of substrate limitation in one of the steps, and wherever you have substrate limitation, obviously subsequent step will not go further, and that will also impact the biomass present in that particular group. Suppose first reaction is become very slow because of substrate limitation, then subsequent reaction will not happen. So the bacteria to do this subsequent reaction will also not be able to get any substrate, and they will die. So essentially, whenever you have death of bacteria or depletion of bacteria, it will actually create problem with stability of biofilm. So you will have disintegration of granule, and you will have instability of the reactor. So that's why anaerobic reactor, particularly biofilm-based anaerobic reactors, are not preferred to handle very low strength or low carbon containing wastewater.
Sir,
Is it clear?
sir, you mentioned hydrolysis, acetogenesis, and then methanogenesis. That these four reactions happens does this happens simultaneously in a bioreactor, or one after another? And can you please explain about this?
It is actually one after another, because they depend on substrate. So hydrolysis will just convert all polymers to monomers. So you have carbohydrate, lipid, fat, carbohydrate, fat, or different proteinaceous material. So it will convert all polymer to monomeric compound. And then here you have polymers, then you have monomers, and from monomers, then you will have, so these are all, so you can say all these steps are actually happening in a series of reactions. So first, this is the initial product or initial substrate. Then this is one of the intermediate. That intermediate will get converted in the second step, like acido. And then another. So here, after acidogenesis, it will form different volatile fatty acids. So volatile fatty acids are again another intermediate. That intermediate will get converted to acetic acid by acidogenesis. and then acetic acid will be used up by methanogens. Methanogenesis, and then finally you will get methane. So these are all intermediates, monomers, VFAs, acetic acid, but they are substrate for the subsequent microbial community. And final product is methane plus carbon dioxide, hydrogen, some moisture, H2S. These are all your final product. So this entire scheme is actually happening in not in parallel. So obviously you will not be able to see a but in a reactor system, whenever you will have production of this, it will automatically get converted to means the activity of the bacterial group present in different step will actually tell you how fast this reaction will go. So inherently we get really very good conversion or very fast conversion for hydrolysis. And acidogenesis and acidogenesis, they are also comparable. Their growth rate is reasonably good in hours. Like you get growth rate in hours in those. Whereas methanogenesis, their growth rate is in mostly in days, say half a day or 2 days, 3 days. So it is they are inherently very slow growing organism, whereas these three are quite good. So they can grow at a faster rate. Now with hydrolysis, so essentially in this reactor system, you can say rate limiting step is methanogenesis. In the series of reaction, the slowest rate is actually slowest rate step is considered as rate limiting step or the rate determining step. So most of system they always try to ensure methanogens should not get affected, or you should try to promote the growth of methanogens. So sometimes they add a lot of nutrients, trace nutrients like nickel, cobalt, because they also this element will actually enhance the metabolic activity of methanogens. Similarly, they also ensure that there is no inhibitor present in the system to inhibit methanogens, because if you have inhibition, there means in normal situation they're growing at a very slow rate. Now, if you get any other presence of inhibitor, their growth rate will get further retarded. So obviously, that is not desired in a given reactor system. So we'll always try to optimize the reactor by maintaining healthy condition for the methanogens. Now, in some exceptional case, you can still get the first reaction as rate limiting step. In cold country, like when DRDO tried to install their anaerobic digester in Siachen this year or in high altitude, they realized that, and it is true with other cold country also, wherever you get really very prolonged winter, their hydrolysis could be the rate limiting step, because hydrolysis is essentially just breaking down of all polymer to monomer. But if you have very cold environment, liquid, particularly lipid component, will solidify and they will not come in contact with the aqueous phase. So it is dissolution of the lipid will be a challenging task. So in those environments, they always try to raise the temperature of the reactor to get inhibition free, or you can say good amount of hydrolysis rate, and then subsequently all other process will also have a reasonably good conversion. And methanogens are quite susceptible to pH temperature. So generally they prefer pH in the range of 6.8 to 7.2. And their temperature also, mesophilic, if you work with mesophilic, then they try to maintain the temperature 37 to 45 degrees centigrade in the reactor to get good methanogenesis. So in some unit or some industry, they utilize certain amount of methane to raise the temperature of the reactor. Because it is not only raising the temperature of the reactor, you have to raise the temperature of the liquid also. And water has the highest thermal heat capacity, like CP is 1. So mostly the raising the temperature of water is important. Because if you need to raise temperature, means 1 calorie per gram of water. So obviously that will be quite significant, and still the amount of methane is generated in industrial scale, it is sufficient enough to raise the temperature of reactor, because if you raise the temperature of reactor maintain at 37 to 45 degrees centigrade, essentially you will enhance the production of biogas also. So suppose you are producing X amount of or X liter of methane, you just spend 40%, and 60% you can still use for electricity generation. 40% for heating the reactor and 60% for electricity generation. Anybody has any other doubt?
Sir, I have a question. Sir, if when these kinds of systems are being used for like industrial productions, let's say for I want to produce methane or biogas, so like when all these reactions like hydrolysis and acidogenesis, all these happening in the same reactor, like will it be beneficial if we want to make a multiple phase reactor in which like
Yes.
hydrolysis is happening in one and next
Yes. Yes.
that is another. Or will it be
Yes.
like more
Yeah.
efficient?
Yes. 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 That is also there. That is also available. So this co-culturing, or you can say simultaneous production of all methanogenesis in a single reactor is possible only the rates are comparable. Suppose the hydrolyzing bacteria has X amount. Their rate is R1, it is X1, it is X2, R2, X3, R3. Now, we know that this R1, R2, R1, R2, and R3, they are almost similar. So if you have X1 similar to X2, similar to X3, then it is fine. Means you will get substantial amount of conversion. Now here it is X4 and R4. We all know that R4 is much slower than R1, R2, or R3. So to compensate that, you have to have sufficient amount of X4. So X4 would be much higher than X1, X2, or X3. So overall conversion will be comparable then. Now it is very much possible that in a given system, even if you have very high concentration of X4, still this R1, R2, R4 are much higher than R4. If you have that kind of situation, then we just split it and then have two different chambers. One for the first three reactions, R1 to R3, and second chamber only for R4. So specifically, it is very true with solid handling reactor system. So whenever you try to digest food waste, and whenever you try to use some system where you have huge amount of carbon, which can be easily get degraded by the first three bacteria and produce a lot of acid, and that acid can inhibit the methane. So to avoid getting methanogenesis inhibition or inhibition of methanogenesis, you just separate them in two reactors. So the first reactor will be a little bit smaller size because you need not to handle too much of solid material to get certain amount of acid which can be handled by a bigger methanogenic reactor. So when you separate them, you have good control on the acid flow to the methanogenic reactor. So whatever amount of acid can be utilized by the methanogenesis, you just add that much. So you try to do this kind of separation where you have easily degradable substrate in the beginning. So it is a common practice for digesting food waste, solid food waste. We prefer to use two different reactors. One is for acid formation, another is for methanogenesis. Otherwise, methanogenesis will get inhibited by the formation of acids. Okay. Any other doubts?
Sir, you mentioned like DRDO is setting a bioreactor something kind of in Siachen. So like DRDO has such kinds of like is DRDO developing bioreactors such kinds of, or is there
Yes,
like
yes.
biotechnology department there also?
They have. And currently they are actually, I am also member of one of their evaluation committee. So currently they are trying to propose an anaerobic digester which can be used in other sector also. So yes, they have biotechnology division. Okay. So any other question on wastewater treatment? If not, then we'll go for the next production line. So we have mentioned about biomass generation, and one of the prominent wastewater treatment is definitely one of the prominent example of use of biomass. Apart from that, in biochemical industry, one of the prominent industry is actually industry for production of yeast. And all of us are actually somehow exposed to different kind of product obtained from yeast. So in our life, definitely we have had tasted bread in multiple occasions. So production of bread is also dependent on, or one of the active ingredients in the bread is yeast. Similarly, in different food supplement, there also we use yeast extract. In different food material as well as in other pharmaceutical product, we also use yeast extract as a flavoring agent. So to enhance the flavor, we also use yeast extract. And typically, when you try to develop any media solution for growing bacteria, there also you need to use trace nutrients. We have mentioned earlier that bacteria also for their growth, they will require macro element and micro element. And in micro element, they will require different vitamins and other minerals. So yeast extract is actually a prominent source to provide those micro nutrients. And yeast extract means first you grow the yeast, and after growing the yeast, you just extract the component from the yeast. So growth of yeast is required, or that is the primary motive in this production industry, where you can grow the yeast in fermenter, and then you follow subsequent process to produce, or subsequent process to produce different kind of other byproduct from yeast. So you can have some flavoring agent, you can have some specific nutrient obtained from yeast, you can have some specific extract from yeast which will be used for the production of certain APIs, active pharmaceutical ingredients, or maybe some additives. So yeast is one of the commonly used organism we mostly use in food industry, and also another major chunk of yeast is used for production of alcohol. So and when you talk about biotechnology, we have also mentioned that recombinant, because in the first class we have mentioned 5 different classes of bioproduct, or bioprocess industry actually explore 5 different ways to produce different bioproducts, and one of the prominent path is biomass production, and then also we mentioned recombinant biomass we use for producing different biomolecules. So E. coli, we know that is one of the well-known and you can say very widely explored organism to use as a recombinant platform. So we just modify the genetic material in the E. coli cell to produce different kind of biomolecules. Similarly, in yeast also, Saccharomyces cerevisiae is one yeast which is a well-known host for doing recombinant, or for using it as a recombinant platform for manufacturing or for producing different recombinant biomolecules. So E. coli is one of the commonly used bacterial strain, and Saccharomyces cerevisiae or yeast is commonly used, say, fungi strain, which is also known as a good platform for different recombinant uh, biomolecule production. So production of yeast is again dependent on, because it is a biomass, so obviously you have to maintain optimum growth condition, optimum temperature environment to get certain concentration of yeast, and then finally you have to just take the broth, separate all of the residual component, and concentrate the yeast by dewatering the system, by removing the water, removing all of the residual nutrients, and then you can process them as per your requirement. You can have yeast slurry, because in some industry they prefer to use yeast slurry. Some industry they will require only dry yeast. Some industry they will require a paste of yeast. Some industry will require some solid bricks where moisture content should not be should be moderate. So based on your moisture content requirement, you just process it and then you sell it to different industry. Now, we have mentioned about use of yeast.
Sir, I have a question about yeast.
Uh-huh.
Sir, you mentioned that we used like a yeast is used for making extract, which is used for like growth medium for different other microorganisms. So, like in yeast extract, like all kinds of nutrients are there, or just like major or minor?
No. So we are not talking about macronutrients, right? We are just talking about micronutrients. So yeast is a bacteria, is a fungal cell. Now, when you have different nutrients like let's say zinc, copper, nickel, selenium, different micronutrients, because their concentration will be very, very low. Now, instead of adding them separately, or different vitamins, they're already present inside the cell. So now adding them separately to the fermented media, one option is to just add yeast extract. So in specific fermentation process, definitely have to rely on some specific bioadditives. So I'm not talking about a specific bioprocess industry. I'm just talking about simple bioreaction. Even in your laboratory experiment also, when you try to grow E. coli, or when you try to grow Sejaimomonas nobilis, in those cases, you just add yeast extract as supplement, because yeast extract will actually provide the vitamins as well as trace minerals to the system. So that's why we use yeast extract. And yeast will also have certain very small amount of carbon, but that is not sufficient enough to provide carbon to the organism. So obviously you will have some other prime carbon source, but where instead of using, in cases, instead of using any vitamin solution or instead of using any trace mineral solution, you just use yeast extract, because yeast extract already has all these vitamins as well as trace nutrients or trace minerals.
Sir, there is a growth medium called Lulia growth. Yeah. So in that is made up of yeast extract, tryptophan, and sodium chloride. There is not other nothing else is added. So like how can that be provide?
No. This growth media are actually not like any other complex media, because in specific fermentation, when you use luria broth, now you, if you have already read about luria broth, so where do you use luria broth? Do you use luria broth for production of any other biomolecules? So
no, like
most
for the formation of colony.
No. For growing certain organism, you use some specific media. So that specific media component will actually help to grow those organisms in the laboratory condition. But when I am talking about production of any specific bioproduct, I know, suppose we are talking about biomolecules, right? So ultimately, suppose you are producing, you are targeting to produce ethanol. Now, to get ethanol, you need to get some carbon from somewhere, because ultimately in the product you have a lot of carbon, C2H5OH. That C2 has to come from somewhere. Now, if you get substantial amount of carbon present. Suppose you are converting sugar, say glucose to ethanol. So glucose has substantial amount of carbon. So in this fermentation process, glucose is your main carbon source because your target is to produce methanol. Whereas urea broth you are just using to grow some organism. You are not targeting to achieve highest possible concentration of those organisms. You are just trying to explore a possibility where organism will get bare minimum food and then they will grow. There, your objective is not to maximize their concentration. Now, in the industry, when I am talking about biomass production, our intention is to convert all carbon to biomass and very minimal conversion of carbon to other byproducts. Similarly, when you try to produce any byproduct, instead of targeting biomass concentration, then your intention would be to convert all carbon to that product and very minimal conversion of carbon to biomass maintenance. So the objective will be different.
Yes.
Now we mentioned that as flavoring agent as different enzyme. Let me just keep on. So we have mentioned about use of yeast in different sector, and so I'll request, means obviously we'll discuss that in the next class also, but I'll request the class to submit a small assignment where you can not now. When I'll finish the entire section with yeast, then you can actually get some more idea about utilization of yeast also. So one is use of yeast, that will be your assignment to submit. So you will just write variety of yeast produced in yeast manufacturing process and their uses. And you will have only few bullet points, and this particular assignment will be of 1 page. Don't try to write a history there. Just variety of yeast or produced in industrial scale and their usage. Now, different industry they use yeast in a different manner. As I mentioned, depending on moisture content, you process them. So final, when you try to get the yeast from the final processing unit, you regulate the moisture content in different way. Like if you use filtration unit, you can have certain amount of moisture in the cake. If you use centrifugation, you can reduce the moisture further, so you will get little bit less moisture content in the cake. If you use dryer, then you can actually get, suppose you are using freeze dryer, then you can actually get completely dried or very minimal moisture in the cell, in the final product. So Saccharomyces cerevisiae is one of the prominent candidate. Saccharomyces cerevisiae. CEREVISI Saccharomyces cerevisiae is one of the prominent candidate of yeast, and so many other strains are also there, but mostly we'll deal with this particular strain. And when we'll talk about alcohol fermentation, there we'll talk about different other Saccharomyces sake, Saccharomyces eugerum, different, and even Candida utilis is also another bacteria, fungi that also used for different kind of food supplement production. So Candida utilis is also a food yeast. Candida utilis is another kind of yeast which also uses food yeast. So they are also known as food yeast. Still, oh, okay. So maybe in the next class we'll discuss about the production of yeast and also the type of yeast we get depending on the moisture regulation. So and after next class we'll get one more class before minor exam. So we'll try to finish yeast and then whatever we will cover till that minor exam, that will be your syllabus for minor exam.
Yes, sir.
Okay.
Sir, do we have to write the assignment or do we have to type it out?
All assignment will be handwritten, so not now. Maybe hopefully by next class we'll finish this part, and so then we get to know what of the type of yeast we are talking about, and also their usage. So usage part you have to just do a little bit of literature search. So I have mentioned about few usage, but you will get more usage when you do the literature search. And that write-up will be only one page, not more than one page, and you will just have some bulleted points, some bullet points saying these are the type of yeast and their usage.
Okay, sir.
And I'll
Yes,
share
sir.
a link. I'll share
And
a link. So using that link, you can just upload your assignments.
on Moodle, sir.
I'll share either a Google Drive link or a SharePoint link.
Sir, in Google Drive, everybody will see everybody, so they may copy each other. Sir,
No,
Moodle is better.
No. If I just share a Google form, we will not be able to see any of the responses. Don't worry about that.
Yes, sir. Yes, sir. Google form is.
So yes. I'll send a Google form, so you can just upload your response there.
So by do that?
Sorry?
By when will we have to submit the assignment?
Before minor exam. So if we finish about yeast in next week or next class or next to next class, it will take hardly 10-15 minutes to write that assignment. And in
Yes, sir.
worst case,
So it will be like 5 marks or something.
don't worry about the marks now.
Okay, sir. Okay.
It always happens that sometimes we do a little bit of alteration of marks distribution at the end, because whatever we promise, if we just stick to that, maybe none of the student will get A grade or many students will get F grade. So to just give benefit to the students, sometimes we give more weightage to that particular examination where student actually scored little better. So don't worry about the marks distribution now.
Yes, sir. Yes. So the grades will be relative.
It is. Only for A, it is absolute grading, like you need to get above 80, and rest of the grades are relative.
Okay, sir.
Okay, then see you again on Friday.
Thank you, sir.
Thank you, sir.
Yes, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Sir, could you please upload the slide again?
Yes, I tried actually this. My team has some issues. Maybe I'll try again today. If I don't get, means if it will not allow me to upload it, then maybe
you
I'll
can
just
send
create a Dropbox
via
link and then
email.
share. Yeah, I'll create a Dropbox link and then share the link with all the students.
Yes, sir. Yes, sir. Thank you.
Yes. Sorry.
Yes, sir. Thank you. Thank you.
Thank you.